Good afternoon. Thanks for joining our session. My name is Guillermo Ruiz, and I'm Senior Developer Advocate at AWS. And with me today is my colleague, Elizabeth Fuentes. Have you guys ever made a mistake that is worth storytelling? Last year, we were invited for the first time to speak here at re:Invent. And we were preparing the whole trip, booking the flights, getting our bags packed and ready to go. But suddenly, things turned a little bit over when we found that we booked to the wrong Vegas. Vegas, New Mexico. Yeah, you laugh, but 700 miles away from here. I never heard that it was another Vegas in the map. It's funny because it's just a single letter that changed the whole experience coming to re:Invent. It also made me sure that I need to wear some glasses to start reading. But with all this, the next logical step is like, gosh, I need to change tickets. I need to start calling support. So we went with the call support. And I'm not sure how it goes on your side, but the experience is something I'll never forget, but not for the right reasons. The wait time usually feels endless. And we got several call drops, and you have to recall again and try to get with the same agent that was speaking before, rather than telling again the whole story that I'm an idiot and I lost the tickets to a different site. And also, we got here a lot of repeating information, and they didn't have really the history on that side. So it felt really disconnected. Not sure if you guys have gone over this thing that you felt like in a loop, never-ending story. But this airline had a new modern chatbot that you could speak directly with an agent. So we went and tried the agent. It's like, OK, this is a modern thing. Maybe it goes much better. But something that we hope was interactive and fun, it turned also into a problem. Systems were failing. They were not able to load out information there. A lot of questions again. What's your name, Guillermo? Which is the flight? And all these things coming on. The problem is that it went over. Huh? The thing is how we feel all these channels, how they are disconnected, right? First is the inconsistency there. How often have you reached out, and depends on the interaction, you sometimes get quick answers, but sometimes it's like kind of a hell. We also have lack of personalization. Traditional systems treat you as anybody else. They don't understand the unique needs or their requirements that you may have on that side. But also there's limited knowledge. And the support agents usually don't have all the database and all the information in a single place to go and fix, which also turns into a pain point on that side. And last but not least is the data security. Here the problem is that with all the interactions we have, we are giving them too much information. And we don't really know if there's going to be a data breach on that side. With all these things together, it really turned into a poor customer experience. And that's where came the idea of our AI-powered travel assistant. Huh? We wanted to make something that could eliminate the stress of travel, try to fix some problems before they happen, and also to provide a fast and personalized support. So whether you're heading to Las Vegas or anywhere else, you could have your application ready. Huh? This is what we are going to build. Let me see, it shows there. Yeah. So we have a set of existing resources. Mainly three kinds. So we have a bunch of PDF with the travel information, the policies from the airline. We have a customer database with the passenger details. And we have a support ticket database for managing those issues. What we are going to do is take all those three to build our travel assistance, and we'll make it like in 3 building blocks. We'll take the first one, and we'll build a knowledge base. This will help us to the assistant to have a specific information about the topic we are looking for. And will help answer questions quickly and, we hope, accurately. And the second thing, we'll get how we handle actions, how we get the passenger information, how we can retrieve all that data. And then last and not least, a way to create and manage those ticket support so we can have the traceability of things happening there. Well, it goes there. What we're going to learn today, we're going to set up a vector database. On top of that, we'll create our knowledge base with the specific information from the airline. And then we'll build AI agents for real-time data retrieval. And we're going to integrate this with your messaging applications. In our case, it's WhatsApp, but you can do it with eMessenger, Telegram, WeChat, or many, many others. By the end of the session, you will have QR codes with the GitHub, with the Gits on all the code, all the sections that you just can copy and paste and replicate and adapt to your needs. So we're building a smart travel assistant, but like any great assistant, we need a reliable memory, a place where all the information is stored and can easily be retrievable. And that's where the vector database comes in. This is the first building block. And a vector database stores and retrieves data in the form of vector embeddings or mathematical representations. This allows us to find similarities between data rather than relying on the exact keyword match that is what usually happens up to date. This is essential for systems like retrieval augmented generation, or RAG, which combines external knowledge with the AI response to deliver those accurate and context-aware response. And by the way, I think yesterday we announced the re-rank API for RAG. So now your RAG applications, you can score, and it will prioritize those documents that has the most accurate information. So at the end, will be even faster and cheaper building RAG. We're going to use Amazon Aurora PostgreSQL with vector support that will give us a scalable and fully managed solution for our AI tasks. The thing is, when we designed this solution, we considered two options there. Amazon OpenSearch managed service that we have, or Postgres. They both work, but they are catered for different things. For example, with OpenSearch, it's ideal for high-speed search and managing unstructured data, so it outstands with log analytics, e-commerce, or even large-scale semantic search. However, with Postgres using PG Vector, we could combine structured and vector data, and it provides the right combination for what we are trying to build today. As usual, it depends on your needs if you want to go with one solution or other and the kind of information you will be managing. So a knowledge base. This acts like a library. We provide AI with the relevant contents it needs to deliver. So what we're going to do is we're going to set up a server cluster, and rather than make it by hand, which has like many tasks because we need to provision many, many resources, we're going to automate the whole installation. And we're going to use CDK, AWS Cloud Development Kit, using Python. There are different CDKs. Again, depends on your skills or what you want to learn. I will give you a tip here also that you don't need to know a specific programming language. So steps to deploy our vector database that on top will be the knowledge base. We're going to deploy the serverless V2 cluster. We're going to create the database secrets, the Postgres table with custom resources, grant all the permissions to that custom resource. And then we're going to config the system manager with the keys to make easy communication and access to our system. This is how it looks, part of the code. We have the first app, Pi, that this instantiates the crate of the project stack to deploy the resources. You have a CDK JSON that defines the runtime and the configuration, and many other files. As I said earlier, you have also a Q developer that can be integrated in your IDE that you just can ask them. Even though I was thinking on using synthetic voice and just letting Q developer deliver this session. You can tell them what does this file does, or highlight a few other things, and even you can have inline recommendations, so it can improve your code. I did it several iterations to get that minimum code function there. And we're going to use and start deploying. First, we're going to get all the requirements, the dependencies, and then we'll just execute the CDK deploy command. It will start putting every single resource, identity access management, security groups, all the access and permission that are required, plus the secrets that we need for the database and the access out there. It's like, if I'm not wrong, it's like 39 tasks. Imagine if you have to do this manually and then replicate this in different availability zones, that you will spend like weeks just to get if you standardize the whole access list, security groups, and stuff like that. It takes a bit to deploy, as you can see there, 16, 21. We get the whole thing, but we get the files of what the things are changing and what are we going to install up there. It took us like 18 minutes, if I'm not wrong, to get the deployment done. And now we can go to the console and start looking at on our stack and see the resources. All those resources were deployed using the code that you will have available by the end of the session. You have there our PostgreSQL cluster. It will open. We got it there done. Looks like we are good to go. We will not check the identity and access. It works on that side. But now that the CDK has deployed our serverless cluster, let's move to configure. And what we're going to do here is we're going to set up the schema, define the roles for the control access, and we're going to create a table that is optimized for semantic search. That's the code we're using. So if database guys, hope I didn't make any mistake in the slide. You got it there. First takeaway. That's Werner Vogels, our CTO. Hope he doesn't ask me for royalties for using his picture. So automation is the backbone of modern infrastructure. By using CDK with Python, we can eliminate repetitive manual tasks, but also minimize the number of human errors. In the old days when we were doing that, it was taking even more time and some debugging and troubleshooting to understand why things were not connecting or were not deployed as we like. Next thing, we have our cluster, PG vector. Let's start building a knowledge base. But before starting with the knowledge base, I want to step back a little bit because we're going to use Amazon Bedrock. And this is the core AI service that is powering the travel assistant. With Bedrock, it allows you to build AI application without having to worry about the underlying infrastructure. The cool thing that is designed to integrate seamlessly with Amazon Titan, but also Anthropic Cloud and many other AI startups and models that you can try. Meta with Llama and other things there. You can use pre-trained models, fine-tune them for your specific needs, and you can connect them to services like PostgreSQL, all while leveraging AWS security and scalability. And now, after this little spoiler, let's get back to our knowledge base. With the database in place, this is going to be our AI brain for the travel assistant. We will process our PDF files, and we'll convert them into vector embeddings, and we'll enable semantic search to find that information that is based on meaning, not just keyword matching. Two services. So I'll use S3 as our data source, and we'll store and update all the files like the PDF, doc, whatever you have. And we'll break them into little chunks, and here's the data ingestion pipeline that we're going to be using. On manageable chunks that will convert in those vector embeddings. And these embeddings are then stored in the Postgres database for the fast semantic. We'll optimize this using chunking best practices. What it means is we'll break data into smaller chunks. In this case, it's default 200 tokens. But also we'll use overlaps. So when you break data into different chunks, there's sometimes that you lose information between those chunks. And with overlay, it allows to repeat words or vector embeddings on this side to correlate so it doesn't lose the whole picture and the context of what we're trying to do. And then we'll see how we're going to make the prompt engineering. Usually this is a it's a two-path. And the first one is going to be, it generates the main question structure while we search in our knowledge base and get the information, and we'll pull that information to do what we call prompt augmentation, giving it the context so it's a bit more smart on the way it will answer back because it will have a more context information thing. Back to our wonderful Q developer. In this side, that's the file that we're going to use and the code. In this one, I was just telling it, can you describe the 3 highlights and why did you choose Amazon Titan for this whole thing? As you can see, it comes there, and the whole file to provision the knowledge base. You can define your class. If you're using other programming languages, it's OK. And here's how it set up what I just mentioned earlier, set up the IAM roles, the S3 bucket deployment, how it configures the knowledge base. It already does the job for you. And why we choose Titan? Efficient retrieval and semantic, optimized for high accuracy, and has more than 100 languages. That is something that we were looking for, that no matter where you are from, what languages you speak, that the travel assistant can reply to you. So let's go again. I promise that these times are less steps. I think there were 19 rather than 39. So, doesn't go. Oops, sorry. Oops. It gets there? No. Looks like we're going to see how we deploy this thing. Huh? 1 sec. Now we got it there. CDK deploy, our 90 resources, again, identity access management, and the whole thing to get it there. But now we're going to see a better view from the console because we're going to see the Bedrock model, what is deployed, all the files inside the S3 bucket that is related, and where it pulls the information from. Huh? Got it there? Yeah. 19, no, 17 tasks, sorry. Huh? As you can see, I should have speed up the video, to be honest. Huh? You got the knowledge base, the custom resources, the Lambda that triggers to process everything that we're going to show up now. And it goes 3, 2, 1, and get it there. Huh? So we'll jump to the console. And let's see what we have there in the stack. That's the knowledge base that will be linked to the S3 bucket that we have. And then we will have all the PDF and the information that we just uploaded. We also have the SSM parameters for easily access and provide that security we're looking for. And it comes there, the airline Q&A base, all the PDF. You can have multiple type of formats. Huh? In our case, we just went with PDFs for this one. But also the SSM parameter, there's the PG vector, ready to go. Huh? Jump into Bedrock. And here we'll have our knowledge base. And with our knowledge base, we'll check and we'll start provisioning the model, and we'll test with what we just deployed. Huh? Here you have all the information. That's the S3 bucket again. And we will select the model. In this one, we'll select Cloud Haiku to do the testing. You can use other services like the model evaluation, where you can just put 3 models, test it, and see which one is the best one that aligns with the needs that you have and how it responds, longer, more technical, whatever. So in here, we're going to say, hey, I want to test if it has the right information if I want to cancel my flight. It will provide the information from the chunk where it took it, but also you can click and it will show you the PDF where it's taking the information. So you have kind of the traceability of where the information is going and getting it from. Huh? Let's see, it goes down. You see there that says 1, and it will highlight the PDF where it's taking the whole information. So the second takeaway here is that the quality of your knowledge base determines the quality of your AI. We always say, if you train everything to have generic information, responses will not be good. But if you provide the context and deep dive on the things that you want it to take, it will really reply the way we want. Huh? And now that we have everything, it's time for the fun part, that is how we build the AI agents. And I will let Ellie to take over and speak about this. Huh? Thanks.
Yes. Thank you. Thank you. Welcome. I'm super glad to be here with you. Now that we have our vector database information placed in a knowledge base, we are going to build a personalized agent. And the interesting thing here is that this agent is going to be capable to resolve our problems, customers, without the need to train a new machine learning model. And for this, the other
big
button, the big one. And for this, we are going to use Amazon Bedrock agents. This service allows the IA applications to be a little more smart using our information, like the knowledge base or different data source as database, like a customer service database or like a support ticket database. And these agents can receive natural language question. Then this agent retrieves information for these different data source to create a comprehensive response using a large language or foundation model. And how this works, this agent? Let's see. First, we need to select a foundation model. This foundation model is going to depend for the capability of our agents. For example, if we are going to build an agent capable to manage different languages, we need a foundation model capable to manage different languages. Then we need to provide basic instructions. This basic instruction could be, you are an assistant for La Inventada Airlines, tasked with providing passenger information and support. But this instruction here is a little small. It's a little small to perform a lot of tasks. And to create a better prompt, we are going to use a structure prompt based in the prompt engineering techniques. Let's see that. In this structure, the first one is the role. And the role is like the personality, like the specialty for this agent. In our case, is you are an AI assistant for La Inventada Airline. Then we have the context. And the context is like the operating framework, the instruction, the task for this agent, in our case, is access and deliver factual information, offer helpful guidance, engage in causal conversation because we want a nice agent, and create a support ticket. The next is the user input. This user input is the information that our agent needs to create this task, to process this task. And for our case is passenger ID or reservation number and support ticket. And the last one is output. The output is the way that we want this agent answer the question. Okay? And for this case, we have clarity, communication, importance, detail, offer proactive assistance, and always reply in the original user language. Why? Why this? Because if we use a multilingual model, we need to guarantee that this model is going to answer the user question using the same language. Because if we don't do that, we don't going to offer a good customer service. Okay, let's do with this. Next, we need to select relevant data source as the knowledge base that Guillermo just created. And we are going to build two data sources more. We are going to build a passenger database and a support ticket database. And last, we need to specify available action, the action groups. And these action groups are get passenger information, create support tickets, get as today data, and as knowledge base. Why I create an action group as today data? Because this agent doesn't know the today data. And we need to, for example, if the user asks, I want to change my ticket for the next Monday. The agent is going to say, okay, next Monday is September 21, 2022. The agent doesn't know today data, so we need to provide this information. Okay? Let's see how this knowledge-based agent integration works. We have this agent is like the organize, something like that, the user request task. In this organization is this agent receives the task and then it creates a little task based on that. For example, if the user asks, I want to change my ticket, the agent is going to create a little task based on that, for example, the next example, the agent is going to do a search in the knowledge base and find the step to change this ticket. Then if the agent needs the passenger ID, his agent is going to ask or to perform a query in the ticket in the passenger database, and so on and so. When the agent finish the step, this agent is going to create the answer using the original query and the retrieval information. And then the answer is going to generate it using the large language model. And then we are going to have an excellent customer service, 5-star, yeah. Okay, let's see how this architecture is looking for. Well, this is not how this architecture is in a high level. We have here 4 Lambda functions. Each Lambda function is an action group. For the agents, the Lambda function doesn't exist. Agents only know action groups. And this description for each action group. We are going to create them, the 2 DynamoDBs, NoSQL database, the passenger table, and the ticket table. And then we are going to integrate the knowledge base that Guillermo just created with this agent. And all this integration is built using CDK. Now, and the code is in this QR code. Let's see how these agents look in the console. Click. It's moving? No, it's not moving. Now, so we go to the console. We click in the tab agents. Here we are, the La Inventada agent. Then when we are in the console, we can test this agent, we can review the agent. Let's see, here we have the name, we have the instruction for the agents, y an assistant for La Inventada, and all the tasks, all the contents that we already created. In the second model, we can choose any vendor or any model. We have here the action groups. Let's see the Ask Today data. This is the more simple action group. They have a lambda, it's half a lambda, a description, and a parameter. These parameters are like a variable. Now we can see another action group here. Let's see the Create Support Ticket. This action group needs information to invoke the Lambda function. And this information that this agent needs is a parameter. Let's see, down, 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 down. Okay, here we are, all the parameters that this agent needs to invoke the Lambda function that is going to perform the put item in the DynamoDB. And next. Now that we have these agents, we can, the agents, let's read this. Agents aren't just about answering questions. They are about providing action that make life easier. But the life is not easier just for our user or for our customer. It's easy for us that we build application. Because when we use this generative AI agent, this application, this foundation model, the life is easier because we can build better application, we can provide better customer service, then using better time and in an easy way. Okay, seamless customer interaction. This agent is an API call. When we have this agent, we can invoke this agent using an API, a simple API. And we can put this API wherever we want. And in this demo, We do an integration with a messaging application where we can have engaged through any channel, text, voice, or image. We can do a smart processing, and we have AI in action. Our customer can have a self-support. Let's see how this looks. We have an integration with messaging application, WhatsApp. When the WhatsApp messenger are received by the API gateway and processed by the Lambda function, for example, if the messenger is text, the Lambda function is going to send this message directly to the agent. But if the messenger is a voice note, this Lambda function is going to send this voice note to Amazon Transcribe, that is a service capable to transcribe voice to text. And then this text is going is sent to the Lambda function and then to the agent. So you can use this with any channel, but because we can remove the WhatsApp API, and we can put then Telegram API, SMS, or Amazon Connect, because now Amazon Connect have WhatsApp integration since Saturday, because on Saturday we launched WhatsApp integration with Amazon Connect. You can integrate iMessage to SMS, whatever you want, because this is a API call. And let's see how this looks. We can use instant query. We have multimodal, because we can send voice note. This is a picture with my daughter, because I did the demo. And we have multilingual retrieval, because if I use a foundation model capable to manage a lot of language, we can talk with this agent using a lot of language. It's multilingual. Okay. Providing support where your users are on their favorite platform makes all the difference. Yes, make all the difference, because you can use the platform that you want to use this application, and your customer is going to be happy. This is the architecture that we just create, we just built. And let's see some key highlights. This application is serverless, because we use Aurora PostgreSQL, auto-scale with demand. It's AI-powered retrieval, because we use pgvector. We have a seamless integration, because we can combine WhatsApp with API gateway, a Lambda function for real-time interaction. And it's multilingual support, because Amazon Transcribe auto-detects language in voice note. Not only the foundation model is capable to detect different languages, Amazon Transcribe too. And we can use Amazon Vector to process several tasks. And it's cost efficiency, because it's serverless. And remember, this application is a demo. It's not a go-to-market product. You can use this application, this code to create a possible go-to-market product. But this application is just a demo, and you need to create a responsible AI application using responsible AI policy. And that's all. This is the resource for this demo, for this presentation. The first one is the WhatsApp Power Rack Travel Support Agent, the presentation that you just saw. And the second one is a building real generative AI app with Amazon Vector and AWS JavaScript SDK. This is an application that you can deploy, and you can use all the agents and knowledge base that are in your console. So you can do a demo using this application using React and JavaScript. and thank you.
Thanks, huh?